Okay, thank you for the introduction. Good afternoon, and thank you for coming. I wish I knew about DevBox earlier, because then that would actually help me with, well, it would help solve some of the problems I'm going to mention in the next 20 or 25 minutes. So my name is Raymond. Excuse me. I'm a postdoc in the University of Manchester in the Manchester Institute of Biotechnology, and I'm in Patrick's lab. So it's a really long title. I should have shortened it, but I think the main point of it is actually the personal experiences part. I'm trying to explain some of the things, some of the good points and bad points that I've had in the last 1 or 2 years with something. So I'll get into it, and then I look forward to some of the comments and questions that you might have. Clearly, I might have been doing something wrong. Prior to project development, there are usually two main considerations that we all talk about. One is the operating system, and the other is programming language, whether it's going to be Linux, Windows, Python, Java, and so forth. But a third, as we mentioned in the earlier talk, is the environment. And this is not actually talked about as much as the other two, in my opinion, but they might include things like Anaconda, Conda, Docker, virtual machines, and an actual server. So in short, it's basically inside what will the program run in. So I think that the decisions for these three are actually quite important, because it actually affects who is going to be hired, who will actually be brought in to help on the project, and more importantly, or equally important, who is going to look after it long after it's been already developed. So what I would like to do is briefly explain what each of them are. I didn't know the background of all of you, so I'll go through it very quickly and the pros and cons of each. And the personal part is what has gone wrong, at least in our case. So when I was going through all of this, I realized that each of them promised reproducibility and rerunability. I don't know if that's a word. And ease of software maintenance. And this could include reproducing the system from backups, and so that it can run on the same system or another system, and long-term support, possibly by someone who is not the original developer. But are they all equal? And I think they're not all equal, and I'll explain that very shortly. But if they each promise the same thing, how would an RSC choose one over the other? Oops. Yeah. So a little bit about me, very little bit about me. I actually have a computer science degree, and my last degree was in 2004 in a PhD. The relevance of that is that these three, the Anaconda, Docker, and virtual machines, actually came about after my studies. So even though I'm a computer scientist, I have to admit I didn't know any of this, and it's just a trial by fire. You just have to learn it. And probably I did not learn it very well. I do remember from the PhD, all the work was done on a computer. That's it. The data that I was using was measured in megabytes. You know, how much has the world changed? So the first one, I'm moving up from bottom up, is the server. It's just a physical computer, and we all know what that is, so I just got a clip art about it. It's a physical computer. It could be networked to another computer, both inside or outside the workplace, and otherwise it has no other dependencies. So the pro is you can easily reproduce it if you buy a similar computer and install the same software. Actually, it doesn't actually have to be completely similar. So in my case, I have a desktop computer at work. I have a notebook computer sitting somewhere there. And they're not exactly the same, but they have similar software. And if I use the desktop, everything looks the same. All the programs are in the same place, and everything's fine. So it's possible to purchase one if you have a research budget, since it is a fixed cost, right? The cons of it is, well, you have to buy a computer, and that is obviously a big investment. Keeping it requires physical space. You need to think about electricity, cooling, physical security. People could steal it. And also, you need someone in-house to look after it and act as a system administrator. Virtual machines, obviously many of you already know about this, but it refers to virtualization at the level of a physical computer. So taking a physical computer and dividing it into separate units. So you can host multiple virtual computers on a single computer. And on this virtualization program, you can allocate how much, sorry, is there a mouse? Oh, is this one? Oh, yeah. So On the virtualization program, you can allocate how much memory could be used, could be given to it, how much disk space, how much network. So in these two figures, this is from Oracle VirtualBox, and you can see on the left, it's a little bit small, but basically you can allocate how much memory, how many processors you should give to this virtual computer, and how much disk space you should give to its virtual hard disk. So if you have it all running, and this was done on a desktop computer, it would look something like this. This is Oracle VirtualBox. In the background with the mountain is my desktop computer, which was running Ubuntu. At the top here is running a virtual computer of Ubuntu, and at the bottom is CentOS. Here, that's actually not running is Windows. As it turns out, if I ran all three simultaneously, my computer completely slows down. So I couldn't take that image. Okay, so the pros is each VM exists independently of other VMs. Virtual hard disk can be backed up, copied, and restored on another system. And sometimes you can even take a snapshot on a live system to do a backup while it's running. The cons is if you have common memory, hard disk, and network, that means that if one of the VMs is computationally intensive, you could affect all the other VMs, and you can actually affect the host system. And the other downside is that some projects actually require the server and the data to be in a physical place that you know. So one example of virtual machines is Amazon AWS. And in one of my past jobs, it was not possible to use Amazon because we couldn't be guaranteed that the data was still in the country that we were in. So with Docker, so this is something that I don't know much about, but my best explanation is as follows. So it's at the virtualization at the next level up at the operating system. And unlike before, we now have one physical computer running one operating system. But on this operating system, Docker Engine is continuously running. And through that, we're starting up various containers. And each of these containers are self-contained with software and configuration files. And multiple Docker containers can be running simultaneously and communicate with each other and work with each other and so forth. So one thing I want to highlight, if you know Docker, you know that if you have multiple applications, an application running through multiple containers, you could specify that in a YAML file, docker-compose, and the file looks something like this. And I've obviously abbreviated it because I didn't want to make this too small. But one interesting thing is that you specify things like working directory and maybe volumes. And working directory and volumes are actually directories on the host computer. And my app's logs is as viewed from the application. So the interesting thing is, and how this compares with virtual machines, is that if you were to drop a file into hello, then the application will see it there. Likewise, if you took a file out of var logs hello world, then the application would not see that file. So they both see the file system. It's not separated between them. So the pros is it's good for programs that start up, run, and end for data analysis, data processing. And some developers do use it to write web applications. I'm not a web application developer myself, but I do know it's quite popular there. I thought that with less separation from the host compared to the VMs, diagnosing problems would be more difficult. I would actually say in my case, it was actually frustrating. So for example, why does it work on this computer, not the other? And I actually thought it has a somewhat steeper learning curve than the other options. So the last one that I want to mention is Anaconda. And this is, as mentioned earlier, it's able to separate instances of Python and R, but it can actually be used for other open source programs, not necessarily Python and R. So software packages are grouped together into Anaconda environments. And the same program at different versions can be installed in multiple environments by the same user. So the users can actually manage environments and manage software versions themselves. So if I run through this example very, very quickly, if I had an Ubuntu host and I ran these 4 commands, the first one would install this program called BWA. So BWA is a very popular program in bioinformatics. And you would install in Ubuntu this BWA program on the host. If I then create an Anaconda environment using this command, activate it, and then install BWA, then this would install BWA into the RSECon24 environment. And what happens is something like this. So in this case, if you run BWA and take the first 4 lines of it, it actually shows the version of the program. So this would be 0.7.17. And if you look at the path of where it is, it's a user bin BWA. And if you look at the path, it prints out this path out. So the path is, as many of you already know, is the sequence of directories that it searches to look for a program. And in this case, it searches, I guess, is the 5th one here. Okay, if I then activate the environment and run BWA again, then I get version 0.7.18. So these 2 versions are different. Why is that? If you look at where the BWA exists, it's in the Anaconda environment. And if you look at the path, the 2 paths now differ. And the difference is that it has prepended the path, which I guess is similar to DevBox, which it has just prepended the path in front of it. And I personally think, I use Anaconda a lot more than Docker, and I think it's a relatively very little setup. It can be installed by user, system administrator, and the user can create and delete their own environments seamlessly. Neither Oracle VirtualBox or any Docker engine-like system needs to be running. And I've had to explain it to other people who are not RSEs or who aren't computer scientists, and I explain it by saying, oh, it's just changing the path variable. It's obviously doing a lot more, but I think it's just an easier way, like the demonstration in the last slide, to explain to other people. And I think it's also ideal for data analysis. I don't think it's very useful for web applications. And the con is that there's less separation from the other choices between environments and the host system. So if I were to summarize this, obviously there are many ways to compare these 4 options, but I've isolated just these 2 things, which is going from left to right, is decreasing complexity of setting things up, and going the other way is increasing isolation from other systems. So we all want less complexity, right? Less complexity means obviously lower financial costs. You don't have to buy a server. Anaconda environments can be created and maintained without any system administrator intervening. So going further right would be better. But on the other hand, more isolation makes it easier to reproduce environments, troubleshoot, find out where bugs are, and so forth. So what has gone wrong? And this is, I guess, what I've been always getting to. As it turns out, this story comes about because I'm not the developer of the software that I'm going to talk about. I'm the person who inherited. So the people who made it left. So I've been doing this for 2 years. They left probably 4 years ago. And other people have done it probably up to around 8 or 10 years ago. So I don't have any communication with them, and I was just given a system, and the system looked like this. So what they had was a server at the bottom, Microsoft Windows Server 2012. So the version of the server's OS indicates how long it had been running. And above that, they put virtual machines, and above that, they put a series of Docker containers. And all of this was communicating with each other. I think the number of virtual machines that was simultaneously running was around 6 or 7. And at first glance, when I first looked at it, I thought, oh, well, it's nice that it's layered like this. It should help with reproducibility. In practice, when something went wrong, it was really hard to troubleshoot this. Was the network connection failed because of the Docker container? Was it because of the VMs? Or where was it coming from? And occasionally, the server's operating system has to be upgraded, or the virtual machine's OS has to be upgraded. And if that fails, you affect many systems. So that was one downside. Another one, sorry, I'll just click this link. Oops. Oh, the link doesn't work. It's OK. I know what that link says. So this actually goes off to another slide. And very briefly, the other problem was this Microsoft Windows 2012 reached end of life last year. So suddenly we were looking at the possibility that we now have to upgrade this operating system. And that would affect everything above it. So this was not ideal. As part of software reuse for RSCs, many of us would obviously want to use modules, libraries, packages created by others, because we want to reuse, not reinvent the wheel. But if one of those dependencies was ever removed or made redundant, then it would be difficult to actually recreate that Docker container, that virtual machine, or whatever that may be. And this is more difficult if the system is actually running, and in our case, it was actually a running system. So in my experience, and I don't have an explanation for this, I'd be interested to hear what all of you think, but I rarely have seen this with Debian, Ubuntu, CentOS, Red Hat packages. But with Docker and Anaconda environments, I've seen that actually much more often. Something has no longer appears, and then recreating that Docker container is now very difficult. I'll skip, the link doesn't work, but there are a couple of slides that you can look at later on. I don't think I would have time. So the last thing is, this is a message on my phone. I don't know if your phones have it. This is my Android phone, and after it reaches 28 days, it gives me a warning that I haven't restarted my phone. And I always find it funny because restarting computers and software to make sure it's continually working used to be a punchline to a joke. Now it's actually recommended by my phone. So due to the previous two reasons, we actually avoided restarting this system, this whole system, for about 2 or 3 years. And ultimately, we had to do it because we had to take this apart and fix this problem. But all this together made us delay the inevitable. So what I learned from it is, obviously, I'm not going to come up and say, well, one is better than the other. In my opinion, if all 4 of them still exist as options for developers, RSCs, and so forth, then they probably have their own advantages. But I think the best thing to know is which one is better over another so that you can choose which one is good for you. So this is all obviously my opinion. For a server, I mean, if you have the money, and if server and data location is not an issue, and you have the physical space and even someone to look after it, then why not, right? Virtual machines is an alternative to buying a new server, but the host computer does need to be powerful enough to support multiple running systems. Of these options, I found Docker to be a slightly steeper learning curve. I don't know what all of you think than the other options, but I think it is worth the time invested as some intermediary between that virtual machines and Anaconda. Anaconda is something that I use a lot more when I do my work, my research work. And it does allow users without system admin access to create their own environments, install multiple simultaneous versions of R, and accommodate legacy code, new code, and so forth. So the other take-home message, I think, is to actually periodically recreate Docker containers in Anaconda environments from scratch. Even if it's running perfectly fine on the system, you just want to make sure that you can recreate the containers without any problems, just to check that it's free of external dependencies. Doing this when we're available, it allows us to confront these problems on our own terms, instead of sometime when we have a research deadline or something like that. And lastly, I'm not yet convinced if layers of environments like the figure that I showed is a good approach. And I think that, as my last concluding slide, I think none of these environments is a good substitute for good documentation. I think some people that I've encountered said, oh, well, the Docker container description is in GitHub. You can just do a pull and everything's fine, but there's actually no documentation that explains anything. So I don't think even putting things on GitHub is a substitute for actual text, like with paragraphs and punctuation. So with that, I want to thank my colleagues in both my current and previous workplace for their patience while I learned all of this. You know, they had to go through days and weeks where it wasn't working, and I just had to tell them to wait. Reviewers gave some helpful suggestions to this, and obviously the organizing committee for allowing us to present this. So this is my and Patrick's email address. So I made these slides with LaTeX. I don't know, are we making slides available to, okay, we will be. But they're also up on GitHub, and you're welcome to do a clone. And our homepage of our lab. Thank you for all of you for attending. Yeah.
Thank you. We actually have like plenty of time left.
Oh, okay.
If you had the extra slides that you wanted to find, we have time for you to do that.
Oh, yeah, sure. I don't know why the link wasn't working. It was supposed to go up to here. So I found out that when module library package is no longer available, substituting it for a new version was not possible because the new version might not be backward compatible. I think all of us know this. And another module that depends on it in turn might also have to be upgraded, and this causes a ripple effect. And solving these, maybe some of you are more experienced than me, but solving this took me hours or days of my life that I'll never get back again. But more importantly, so one of the web applications in question was developed using Ruby on Rails. I don't know Ruby, and I don't know Ruby on Rails, but one of its dependencies was apparently removed because of a licensing issue. And that set a cascade effect that meant a lot of packages that depended on it also could not be downloaded again. So yeah, that was the cause of my stress and grief. So if you look at the slides, this link, I don't know if this, it's okay, I won't click it, but this link will take you to a page that explained what was being removed. Yeah, and that's it. Thank you.
Thanks. Okay, we have some questions. And just to say, like, the thing about the dependency thing, I mean, like, that's a capital H hard problem, right? Yeah. Like, I think we've all experienced something like that, where the pros and cons of pinned dependencies.
Yes.
So we have some questions in chat. Some of them are kind of suggestions for other tools that you might find interesting, so we can't go through those. But our first question is from Loic. How does the recent issues with Conda licenses impact this? Is this something that you've run into? So the fact that Anaconda has had some issues around licensing for academic and not-for-profit organizations. Is this something that you've encountered?
No, I have not encountered that. Yeah, I'll have to look up into that, but yes, I wasn't aware of that.
So I have a question before we kind of look at some other alternatives. Can you speak to the, I mean, you talked about the complexity of these different levels of sort of abstraction. Can you talk about your experience of like, of configuring, so not just like setting them up in the first place, but like managing the configuration of these different levels?
So while it was running, obviously I couldn't touch it. And of course I cannot explain to my colleagues and my boss, oh, I want to take it apart and see if it's working. Because they're going to say, well, if it's working, don't leave it alone. So what I would do is try my best to do it on my own system and see if I could reproduce it. And before it crashed, I'll explain that later. Before it crashed, I did actually try to reproduce on my computer, and I failed, and it took like a week or 2 weeks. And I wasn't, because of all these dependencies, I was unsuccessful with that. So that's as far as I got. As for the crash, our building had so it was actually about a year ago this month, the building had a power failure. Yeah, and the power failure knocked it all out, and I just had to allocate time from my research to fix this then. Yeah.
Okay, so Laura asks, how does your environment affect the performance of your software when considering the context of these different levels? So in the case of the situation that I'm talking about with the web application doesn't actually have a lot of users. It has enough that it doesn't slow things down for the end user. So the levels that existed then was fine. We didn't end up getting any complaints and all that. When we're doing actually data analysis, so I work in bioinformatics and analyzing biological data, I tend to use Anaconda, and I guess like DevBox, there's actually very little effect in terms of affecting speed. So that's actually fine. Yeah. And like at the other levels, do you see problems? Like when you've got this system that's got 6 virtual machines running it, and then like the Docker on top of that, have you seen like noticeable performance just switching to like pure Anaconda?
Yes, I did. I mean, even if you allocate, for example, if you allocate memory to each of the VMs and the total memory is still less than the memory of the computer, but if each of the VMs is writing to disk, then it's still going to be writing to the disk simultaneously, and it's going to be competing with it. And I did notice a slowdown. Yeah.
Okay. So the most voted thing is not a question, but it was saying that they really enjoyed your talk.
Oh, thank you.
And it was very refreshing to hear a non-opinionated comparison that shares some of the challenges of different approaches based on real-world experience. So that's had a lot of people kind of agreeing with that. Like,
oh, thank you. I thought it was kind of interesting in that I think a lot of people who talk about these systems, they're the person who's developing it, and I inherited it. It was a decision made, and obviously the person has left, and they've gone to greener pastures, and I'm limited in how much I can bug them.
Yeah, I think a lot of us have experience of like legacy, inheriting something and just having to deal with the choices that somebody else has made, and they're now living a free life.
Yeah.
So we've had several people kind of chime in on other solutions that may be interesting for you or other people. So, my thing keeps like moving about. Somebody has suggested like UV or Mamba, which are other like UV is like a Python specific thing. Mamba is like an alternative to Conda. Laura has said that like talking about infrastructure as code, so things like Ansible and Terraform for managing the VMs and Docker in like a code-based way. And Ghislaine has mentioned, I don't know how you say this, GUIX? I only ever see it written down, GUIX or Nix, which are again similar to DevBox that Linus was just talking about. So lots of.
I can see these questions after, right? Like
Yes, I think so. Yeah,
They're
but
not
you can see
deleted
the
after.
questions.
Yeah.
Okay, and a last question, then I think that's time from Sarah. Since working on your nested server VM Docker system, how has the architecture changed? What does it actually look like now? Have you scrapped all of that and you're just Anaconda on, well, not bare metal, but on the operating system?
So some of it has been redeveloped. The applications have been redeveloped and moved to also VMs at the University of Manchester's IT services. That system itself has now been stripped clean. The server is now an Ubuntu server, and it's only running one thing. Yeah. Fortunately, we were able to move the others to other VMs that is actually managed by IT services at the University of Manchester.
Okay, thank you very much. And with that, let's thank our speaker again.
Thank you.